Hi, for this next section, section 2 of chapter 3, designing samples, it may be useful to also have the filled out notes available or to pay attention, make sure you can see this. I'm going to be filling out words, but I'm also going to be revealing sentences that you're going to want to fill out into your notes section. So do as you like. You'll also probably want to pause the video at times so you can write down the bigger ideas. This is the type of notes where it is going to be very handy to just have the filled out notes yourself. However, I am going to be adding ideas as we go along this, so listening to it can also be helpful for sure. So we're on section 2. Remember I said section 2 and 3 are really about the two ways we obtain samples from a population or bigger ideas we can generalize. The one way is to get samples from the population. That's what we're talking about now. The other way is to kind of generate our own data by doing experiments. That'll be the next section. So we're on the sampling part. This is a very, very common way to get information. So suppose we want to gather data. If the group is small, for example, all the students in this class, we can study each group member directly. And when you do that, that is called a census. C-E-N-S-U-S. Sure, you've probably heard of it. Realize that a census is the attempt to gather all of the data. It is not necessarily getting all of the data, which can arise some problems. If, however, the group is very large, for example, all students in the school, studying each member of the group may not be feasible. Now realize if I was interested in, say, the average GPA of students in the school, census would be fine. I have all the information on the computer, we should just get the answer. However, what if we're interested in the average number of minutes students do homework each night? That would be harder. We don't have that information already. You'd have to gather students, we would sample, and that's what statistics is all about, sampling. So as an alternative, we can select a smaller group of people who fairly represent the entire group. Realize that's the big idea. This group of people need to fairly represent the entire group somehow, and that's what takes a lot of thinking. The entire group of individuals, not necessarily people, whatever they are, could be rocks we're studying, that we want information about is called the population. Defined last section. The part of the population we actually gather data from is called the sample. In the world of Venn diagrams, we realize the population and the sample look like that, the sample being a subset of the population. The method we use to select the sample is called the sampling design. So we plan before we go out and get the sample. The design of the sample is very important. If the design is poor, the sample will not accurately represent the population. Keep in mind as we go, we're going to learn a lot of terminology and ideas, but there's a very common sense approach to what we're doing. It's our goal to accurately represent the population when we only have a sample. So we have to think about what we're going to do and how it might introduce biases and problems, systematic issues with it, and what things we can do. So there's definitely some common sense approach to it, but it really is an art in the vocabulary that I'm about to teach you and teach you how to avoid things and how to get things done correctly. So first look at the type of things that happen that aren't so good. So these are really poor sampling designs. They are too. Voluntary response sample is one we're going to talk about, and convenience sample. Let's start with this one. A voluntary response sample. You've been a part of a voluntary response sample many times, I'm sure. This consists of people who choose themselves by responding to a general appeal. Come vote for this, that kind of a thing. My example I have here is, excuse me. American Idol voting, where people from home decide whether or not to vote. People who vote are not representative of the general population. Realize that's not necessarily a problem. For American Idol, that's a really smart idea, what they're doing. Business-wise and trying to actually find out as who should win, that's a good idea. However, that is not going to accurately reflect the whole population's feel on how that looks. So that's not a really good sample in regard to learning about the whole population. Problem, people who have stronger opinions than average are more likely to respond. This makes the sample not representative of the population. We can often we'll talk about different biases, but that we call that often selection bias. We're getting certain types of people to respond here, and we can kind of anticipate how they'll respond even. Next type, also very common, you've been a part of a lot of these, a convenience sample. Individuals' responses who are easiest or most convenient to reach are chosen. We just get the answers right here and call that it. Not necessarily a problem always, but it's a problem if I want to call my answers representative of a whole bigger population. So the example I bring up, in an attempt to learn about, say, salmon in the ocean, we study the ones that we have caught, missing the ones we can't catch. Therefore, getting an unrepresentative sample. And realize the problem is that, here's the problem, that there's often a reason why certain responders are harder to reach. Right? There's a reason why we're not catching those other salmon. And that makes the sample obtained not representative of the population. For instance, there's probably something about those salmon that makes them not easy to catch. It makes them different with regards to whatever value we're trying to estimate. So those are not great ways to sample, and we can often estimate the kind of biases and under or overestimates that might result from those situations. So let's take a look at some good ways to do it. Really, here it comes down to random selection eliminates bias from the sample choice. If you notice, the two methods before had nothing random about them. Look how all these methods will have a random type of selection, like we talked about last section. How about some acceptable sampling designs that do incorporate representative randomness? So an SRS, a simple random sample. We talked about that last section. We didn't talk about it in regards from sampling from a finite, that means not infinite, a finite population though. So let's see how that might look. This is a sample, remember, in which every possible combination, or every sample of the desired size, has an equal chance of being chosen. We talked about ways you can do that using number generators and things like that. I'm going to give an example here. I remember to put the pen down from the slide thing, sorry. So say we write student names on cards, we put them in a box, we shuffle that box really well, and then select cards without replacement until you have the desired sample size. The idea of names in a hat, is really the only way to get an SRS, whether it be using a number generator, that's kind of like a names in a hat kind of thing, with or without replacement, depending on what your needs are for that, or even a random digit table, or names in a hat, with ping pong balls, and the urn shuffling around for the lottery numbers. Now, I'm going to use an example of a scenario. Let's say you're at a bookstore, or you're online reading on the e-reader, and you're trying to figure out, do I want to actually buy this book? Well, whenever you decide when to buy a book, you usually take a look at a sample of its words before deciding to buy. You don't look at the whole population, you don't read the whole book and then decide to buy the book. In other words, you don't gather a census. Right? Your data consists of reading a couple pages, a couple lines, and taking a look at it. So I'm going to use that idea of sampling from a book in all of my upcoming examples to have a nice kind of line go through all these that we can kind of connect them and compare. So let's say when sampling a book's pages to see if you want to buy it, let a random number generator select 10 pages without replacement to sample. That's a very obviously sophisticated way to do something in the bookstore, but we could do more general ideas. We kind of flip to certain pages randomly. Right? That wouldn't be a perfect random way to do it, but that's definitely the kind of idea. And then you look at those 10 pages, and that's your sample, and you'd say, do you want to buy the book or not? So that would be a way to get an SRS. Realize in your technique, any 10 pages would be just as likely as any other 10 pages. That's the key. That's what makes it an SRS. Let's look at the next one. The abbreviation is SRS, but we don't call this an SRS. It's a stratified random sample, defined as the population is first divided into strata, plural, and then a SRS is chosen from each stratum, singular. So basically it's broken down into different groups. And then in each group, we get a little chunk, a little sample from each group. This is used to keep certain ratios evident in the population and consistent in the sample. Before I bring up these examples, we can think about how we might want to do this in our school. That would be a great idea even when it comes to average amount of homework. Right? Freshmen likely do less homework than juniors and seniors. So it might be a good idea to stratify. We'd say I want 40 people for my sample, and there's roughly equal amounts of people in each grade, and each grade has different answers relatively so with respect to study hours and homework hours. So I might say, let's get 10 people from each grade. I'd get a random 10, a random 10, a random 10, a random 10, and I'd put them all together as 40, but I know I've upheld that ratio that I wanted to. Realize, for that reason, a stratified random sample can be better more representative than an SRS. An SRS could easily just have, say, more freshmen than I'd want in the sample to be representative, and I had more freshmen, they studied less, so I would be underestimating the true average because I have more freshmen. So again, it helps you, common sense approach, remember, it helps you just get a sample statistic that's more like the population parameter. So here's the example I delivered. You randomly select 10 students from each grade, 4 grades at PVS, to constitute a random sample of the PV student population. That's the example I gave. Realize that's a good idea when it comes to study hours, things like that. That wouldn't be a good idea for everything. I don't think that would be necessary for if I wanted to know, the gender distribution percentage of boys and girls. I don't think that's different from grade to grade, so that would be probably a waste of time. It probably wouldn't hurt, but it's probably a waste of time. Let's go to my book example. I want to buy a book, let's see. So when sampling a book's pages to see if you want to buy it, you take a simple random sample of, you just get 2 pages from each of its chapters. So you realize the chapters would be the strata. Each chapter would be a stratum, and I would sample from every single stratum, every single chapter, but just 2. And it'd be random 2 for each one. That's not a bad idea with a book, especially a nonfiction book, when it can be that every chapter can be quite different from one another. You get a good, more accurate representation than just a random 10 pages. Next, a random cluster sample. Beware, these two, stratified random sample and random cluster sample, have similarities, but they're actually quite opposite in a way. I'm going to be careful and be sensitive not to tangle them up. This is when you randomly choose one or several groups, clusters, of individuals from the population. And this isn't necessarily better than an SRS. It's often used when you can't get an SRS. It's not possible to get an SRS. That can happen. Often we'll talk about why you might want to do that. It's considered acceptable though. Before I move on, realize the difference. Both have to do with having the population into groups. With this one, I purposely break them into groups because I feel like the groups are different. And then I get a small sample from every group. So this is, I get a small sample from every single group. This is not. This is, I have in the different groups, I hope that these different groups, clusters, are relatively the same. And then I randomly choose the clusters. Maybe I say I want to randomly choose 2 clusters, but then I get the entire cluster. I sample the entire clusters, and I ignore the other ones. That's why they seem like similarities, but they're very different. One example we can add. Select 10 homerooms in the high school at random, and then get the responses from every student in those 10 homerooms with regard to the average number of minutes spent on homework or studying. That might be not a bad idea. Why? People in homerooms are relatively alike. The people in this homeroom, my homeroom, are relatively alike as Mrs. Giorgio's homeroom and all the other homerooms because it's just by last name. I have to be sensitive to if we have any twins around and things like that. I might get more of the same types of answers. But other than that, it's not a bad idea, and it's very realistic to have to do that in the morning, for instance. But we get every single students in those 10 homerooms, every one of them. And notice there are other homerooms we don't get at all. Those homerooms we get everybody. Back to the book example. When you're sampling a book's pages to see if you want to buy it, you randomly pick 2 chapters and you read those entire chapters. Right? Hopefully they'd be shorter if you're just sitting in the bookstore, but realize that'd be a good way to do it. I don't think that would be a better way to do the sampling than, say, a stratified or a sample random sample, because you're just reading about 2 chapters entirely. Right? Honestly, I think that'd be a better idea if you're not going to buy the book, just to learn something and move on. But it wouldn't probably accurately reflect the whole book in this case, but it would be how you could do it. I think I'd go down. Next, notice another abbreviated SRS, but it's not an SRS. We don't get that. It's a systematic random sample. Look how the systematic part works into this. Remember its name. The names do give them away. A first member is chosen randomly from the population, but then it's every nth, 5th, 6th, 7th member is also chosen thereafter. This is also used when you can't get a simple random sample. Think about why this might happen. What if the population is coming at you, people marching in a line, and going by you too quickly to get a census, to get every person's response for whatever it is you're trying to get. But say you do have time to get maybe every 5th person's response. So how it would look is I'd randomly pick a number 1 through 5, 3. I get person number 3, and I'd get every fifth person thereafter. So I get 3, then I get 8, and then 13, and 18, and back and forth. All right, so I'd get a fifth of the population. That can be totally acceptable. Again, it's used when you can't get one of the other ones. It's not necessarily better, but it's acceptable. Get a list of all the students in PVHS in our high school. Randomly pick the first student and then choose every fifth student thereafter. I used fifth and fifth here. It doesn't have to be every fifth. It could be every sixth, every seventh. It depends on, well, two things. How quickly you can get the data as they're marching along, but also how big you want your final sample size to be. Think about that. The book example, when you're sampling a book's pages to see if you want to buy it, you randomly pick a page and then you read every 10th page, say, thereafter. Right? This is actually a pretty common way people do it, right? You usually look at the beginning and you just flip about the same amount, flip about the same amount. That's a very ad hoc way, not super structured way to do it, but that's a pretty common way people do things, and it works. It works pretty well. We have one more type to add to our list, sort of. Multi-stage sampling. I say sort of because this actually is combining the other ideas. It's not its own method, but it's a way you can combine the methods or do the one type of method over and over again to keep breaking the population down into smaller and smaller groups until you can go in and get what you want. So we select successively smaller groups within the population in stages. Each stage may constitute any of the above techniques, right? Hopefully the good ones. An SRS, simple random sample, a stratified random sample, random cluster sample, or a systematic random sample. So my example I bring. Select several departments within the school, say math, English, art. Then within each of these departments, we randomly select several teachers. Then we randomly select several students within each class. You can see we just kind of go in, keep breaking it up into smaller parts. For my book example I have, when you're sampling a book's pages to see if you want to buy it, randomly select 3 chapters. Then randomly select 1 page within each chapter, but then read all of the following 12 pages from that page. Right? So it's multiple stages, really, multiple methods put together. So those are the acceptable ways that we're learning about how to sample from a population so we can keep it reflective of the population. Realize there are 2 things at play. Well, which technique might be best, but also which technique might be most plausible for the scenario. We have to keep those in mind, but those are all acceptable ways to do it. So I say, although this random selection eliminates bias from our choice of sample for the most part, it doesn't guarantee that our sample is representative of the whole population. Potential problems include, so here are a couple ones, and usually if you have a random sample, it doesn't happen, but we're going to be aware of these types of errors that we could have. For instance, undercoverage. Undercoverage. A sample where a certain subgroup of the population hasn't had a chance in the sampling. They've been left out for some reason. Think about the step with cluster sampling. We may leave out a whole bunch at the side who are different, we don't get them. For instance, the example that I'll bring up here. In an attempt at a census during homerooms would miss absent students. We do this all the time with voting for officers and things like that. We try to get the whole census. Everybody does it, the things in homerooms, right? And they do their voting, and we systematically are going to miss absent students. Whether we think that's a real problem or not, it's up for debate. But more importantly, we can't say that the voting would necessarily accurately reflect the population, because the people who are absent are often a more unique type of person on average than people who aren't. People who are absent, maybe they're in ISS, they don't have TVs in there to watch that, they're in out-of-school suspension. Maybe they're habitually skipping school. Maybe they're just sick a lot. There's also some people who are just absent, but there might be something systematic about it. Next, non-response, and sometimes we call it non-response bias sometimes, if we can predict what the type of bias is. Responses are not obtained even though they're desired for the sample. Notice the difference between these two. Undercoverage is my sampling technique misses people. In this one, my sampling technique is fine. I just don't get the answers that I want. The name gives it away. No response. I don't get the response. I want it, but I don't get it. I'm trying to sample it. So I want to get a random sample of my friends' answers to a question. But when I call them, some don't answer the phone. So I get no response, right? I missed that. I might systematically be missing a type of response when we do that. Example with the books. When sampling books pages to see if you want to buy it, you try to collect an SRS of pages but you can't read any of them from the end of the book because someone spilled coffee on them. So it's a silly one, but notice that I want the answers and I can't get them. I do realize that I missed this example. Just going back and going over it. My book example from under coverage was when sampling a book's pages to see if you want to buy it, is sampling a random 10 pages from the free downloadable demo that you can get on your Kindle. So if you have a Kindle or any kind of e-reader, then often you can look at a sample and you usually see the first chapter. So that's under coverage because I'm not seeing any of the others, right? That's in the design itself is the flaw. All right, response bias. Now this isn't a type of something that we can avoid. It's something we have to be aware of and think about. So response bias is always prevalent. It's when the responses obtained are not the correct responses. Basically, they're not there. When I mean not correct, they're. I should back up. Actually, I'm thinking of the wrong one. I'm thinking of sampling response. Excuse me. Let me backtrack here. Response bias, I should say, is something that we can anticipate and should do something about. Forgive me. This is when the responses obtained are not the correct responses. In other words, they should be something, and for some reason they're not, and it's due to something usually systematic in the approach of our sampling. This can be due to many reasons. People lying. I might be able to predict why they'd lie. Some incentives. The confusion, the wording of the problem, or priming. We'll talk about that. I also have a project that we do in my class. I have posters, at least right now, all over my room from students doing the projects where they try to prime people to give responses that they wouldn't otherwise give for one reason or another. The example I have for you, for your notes, students could lie about their alcohol consumption when asked by their teachers, right? I want to know, say, the percentage of students who have tried alcohol, say, sat down and had at least 2 drinks at one time without their parents knowing or something like that. Obviously, a teacher asking might not get the actual responses. I have to be more clever than that if I wanted the answers. Example with the books pages. When sampling a book's pages to see if you want to buy it, but you accidentally pick up the wrong book to draw your sample. It's a silly one, but then look at it again. I wouldn't actually get the correct responses. I'd be reading them from a different book. That wouldn't work. So I don't have anything for you to fill out your notes, but to think about these lines, how this could happen. Poorly worded questions can easily result in an unintentional or sometimes intentional response bias. Say, poor wording can often result in response bias or just meaningless data. I have 2 examples that kind of go in tandem. Say I give this as my question. In a recent study, students in an Algebra 1 course were given a 25-question basic skills test. On average, students used a graphing calculator to answer 21 out of the 25 questions. Do you think graphing calculators are overused? Versus the second question, if I ask it this way. Same question, realize. By using a graphing calculator, students in an Algebra 1 course are able to make visual connection between equations and their graphs, reinforcing difficult concepts. Do you think graphing calculators are overused? So notice the same question. The first one is more likely going to get people to say, yes, I think they're overused, right? Which is going to overestimate our actual true answer. Whereas the second one, people are likely to say, no, I don't think they're overused, that works well. So I would likely then therefore underestimate the true answer. So a better way to ask the question would just say, let's take the priming out of this, kind of call that priming, and say, in Algebra 1 courses, do you think graphing calculators are overused? Done. Now hopefully get a better unbiased answer. Hopefully people understand what they're thinking about. Example 3, do you like English or math? It's not really formed very well. I don't know what the question is really trying to get at, what they're really trying to do with it, so we need more information. Or another one, you get asked this a lot of times. Do you like school? That's a whole host of questions. I'm not sure what people are asking when they ask that. Maybe like certain parts about it, but and overall, it depends what you're asking. So we got to think hard about the types, not just the who we're getting. If we're asking a question, the type of question we're asking, where we're asking that question, who's asking that question. It's a common sense approach, remember. We want to make sure our sample reflects our population. So here's the one I accidentally started talking about earlier, sampling error. Sampling error is a type of error that is just there. It's just there. It's not a type of bias. In other words, I can't always predict exactly what it's going to be, but it's evident. It's the difference between the statistics that result from your sample and the parameters from the corresponding true population. They're inevitable. You're not going to get the exact mean number of minutes people study for homework if I just get a sample. I won't. But I hopefully it's close. So I say this is inevitable in sampling, but can be reduced by good sampling design and increasing the sample size. Probability can tell us how bad our sampling error may be. More on this is forthcoming. In fact, a lot of our upcoming chapters are going to be about sampling error. We get to learning how to do that. So my example, when sampling the types of dog breeds at SPA shelters, we estimate the percentage of beagles to be 15%, because that's what we got from our sample. That was our statistic. Whereas there are actually, say, 18%, I made that up, 18% beagles at the SPCA shelters altogether. So that's the true population parameter, and they differ by 3%, just naturally because I sample. I have to be aware that that might happen, and I have to think about how to reduce that as much as possible. My book example, when sampling a book's pages to see if you want to buy it, you happen to just read many pages that don't interest you, when in actuality the book as a whole would be very interesting to you. That can happen easily, right? That's sampling error. So the last way I'll finish this is say, remember that the purpose of sampling is to obtain good estimates, statistics, for the actual population values parameters. Even though there are many mentioned designs and lots of vocabulary in this section, remember that the ultimate goal is to obtain, I would write this, get this lingo going, to obtain sample statistics that are as close to the abbreviated population, population parameter, say population parameters, as possible. Make that your goal when designing samples. And again, if this was hard to see, feel free to look at the filled out version that you should have access to.